Okay. What are we doing?
With conviction.
Yeah, push the button. This is our leadership team. This is you guys here. So big thanks to everybody here. Bill and Steve couldn't make it out today, but they're here with us. They're with us. Yes, they're here with us in spirit. Also, our sponsor, Matrix, which provides the room and the AC, which is awesome, and the food. So make sure you thank them. Our speaker today, which apparently got cut off. I won't read the slide here. If you're here, you probably know who he is. So I won't read that to you. He's going to talk to us about Xamarin and PCL. He drove all the way from Austin, so make sure you thank him afterwards for making the long trip up here.
Eating all those kolaches. Oh, jeez. Oh.
And our next meeting, we'll be celebrating the 3-year anniversary of Xamarin.
Wow.
Yeah.
I didn't realize it was that.
They've actually been around for 3 years. Time goes fast. You're writing good code, I guess. And then that's it.
All right, thank you. Let's see how this goes. That is a bizarre resolution. Let's see if we can fix this. Okay. That's a recommended one, I guess. Oh, that's better. Spinning wheel of death. So you may have heard a noise. This is an old MacBook Pro with an actual spinning hard drive, so you have to bear with me as it thinks, as I perform it. Oh, come on, you got it. I'm due for one like in a month. I'm super excited. I knew I was pushing my luck with 3 Visual Studios open. You know what?
You use Outlook on there?
No.
Mail it?
No, nothing like that. Just, you know, Minecraft, Minesweeper. That's the mines. I've got them all taken care of. See if I can alt-tab. Does alt-tab work? Man, when Process Explorer is slow, you know you're having a good time. I'm going to say this is Google Plus's fault. Google Plus, through parallels, with Windows, projector, spinning hard drive of doom. No, Windows tab doesn't work, obviously. Oh, man. Oh, I think we're back. I think I'm back. Okay. Whew. My God. Here we go. Okay. So yes, my name is Jimmy. You can find me at my blog at jimmybogart.lostechies.com. I tweeted Jay Bogarts over here, and everything you see today, code, slides, everything, is going to be on my GitHub at github.com/jimmybogart. And I blog on Los Techies. I wrote a book that no one should read because it's a bad book. I wrote a library called Automapper, which people use. And I have this thing, which means you can't argue with me ever, this MVP thing. Although they keep giving to me an ASP now, which I've done in like 4 years, so I have no idea. I don't think they know what I'm talking about anymore. So yeah, today I wanted to talk about specifically cross-platform development with portable class libraries. A lot of actually what I'm going to be talking about is some of the things I had to do to make systems I work in start working cross-platform. A lot of the things I work with aren't cross-platform, and we're trying to make them be cross-platform. And specifically looking at what to do with OSS libraries as well as actual projects to say, we have something that's working on the desktop, how can we make it work on mobile? Or we have something that's working on one mobile device, how can we make it work on multiple mobile devices? And a lot of times you get the answers like, Xamarin, yay, it'll just work everywhere. But you have to do a lot to make it actually work on these different devices. So I want to talk today about some tools, patterns, and techniques that I've used to take libraries that I use every day and systems I use every day to say how can we actually take them from point A to point B to actually make them work on mobile devices. I work for Headspring, and we are hiring. And here's some bullet points to describe the good things about working at Headspring, which you can read thusly. Specifically in Dallas, we are looking for front-end and mobile developers. So if you're interested in working in a place that actually works 40 hours a week and actually has stable revenue streams, it isn't like a can you cash your check on Monday because Friday is kind of iffy sort of thing, which I've worked at those sort of places, then give us a call and we'll be happy to go forward. We do actually. Contract 1090, I guess it's the 1090 401k. No, that's not it. W2s, yes, thank you. And all that stuff. So, I want to talk a little about what portable class libraries are and why they even exist. Because up until a few years ago, it didn't really seem like people were really caring a lot about cross-platform development. I know this is a mobile.net user group, so obviously the answer is mobile is why people care about cross-platform. And specifically, portable class libraries are meant to try to solve a problem of how can we take a code base that works on one platform and try to make it work on multiple platforms. .NET for the longest time had .NET Framework working on a lot of platforms. We had Silverlight, which I guess some people made a poor decision to go ahead and try that. They're liking that. Windows Phone, which I guess a couple of people here might have. Usually if I go to a tech ed or something, there's that's like the entirety of the Windows Phone app group. And of course, regular .NET, but really when you start looking at Android and iOS, which are obviously huge user bases, this is really where you start to see people start to really look at cross-platform as something that's actually viable. Well, up until portable class libraries, in order for you to build a library that worked on multiple devices, this is the sort of thing you had to do, which is basically build. You created one project, which was your base project, and I'm just going to get my laser pointer because there's any cats around. I want to play with them. If you wanted to build a library that worked across all these different platforms, what you typically had to do is create one base set of files that were the kind of core system you're working with. And then you create a series of like 1,000 other projects for every single platform you wanted to be able to support. And anytime you needed to change something on one of these platforms or add something new, you had to make sure and go change all the other projects to include those. Has anyone tried to do something like this before? Like the add as link was your friend. If you added one file, like, oh crap, I got to go add it 1,000 other places. There are like really funny tricks you can do with project files that hopefully are getting fixed based on what I've seen in tech ed in the past couple of days. Probably going to be a while though. But this is basically what you had to work with is just an absolute nightmare of having to work with all these different projects. And then you get to the issue of, well, this one class or this one feature doesn't exist on these other platforms, so how do I deal with that? And the typical answer is these compiler directives like pound if Silverlight do this thing, pound else do this other thing, and sort of sprinkle this liberally across your code to make this one code base try to work on all these different platforms. And then you try to test that to say, well, it compiles, but does it actually run the way I expected on all these devices and all these different platforms? And it becomes really difficult to do and understand. So what portable class libraries are trying to do is try to collapse this down into the subset of actual APIs that really share between all these different things. It seems like the way that Microsoft decides if a certain class type or method, or class or method or assembly is going to exist on one of these other platforms is a dartboard, I think. They're like, should this method exist? Answer is no. Okay, we won't put it in there then. And for you as a developer, as you start to try to make your library go cross-platform, these are the kinds of things you run into. Having to deal with these issues of things being missing on all these different platforms. So what Microsoft is not trying to do is try to create something like .NET Micro framework, if anyone's ever messed with that, which is this idea that I can have a framework that runs everywhere. It's not trying to do that. With portable class libraries, it's trying to look at the subset of APIs that do exist on all these different platforms and say, how can we make someone compile once so that when it runs on their device, it actually chooses at runtime the right platform. And we'll actually have to see how that works here when we get digging into the details. So before portable class libraries, trying to get a library or application to run cross-platform was basically a non-starter. It was the same cost to make an application run cross-platform on Silverlight and WPF as it was like Silverlight and a Banana. I mean, it's just like they were so completely different. You had to re-implement so many things that it became just cost prohibitive to try to do something like this. And in fact, the OSS library that I developed, when I first tried to develop a different platform that I guess 2 people were asking for, Silverlight, it was such a nightmare. I wound up removing support because it was so much work to deal with having all these different projects. So the idea behind portable class libraries is trying to remove the complexity of targeting all these different platforms. And what we're seeing out of Microsoft is this is not something that is just a, make the developer shut up. This is something that they're actually really heavily investing in. You see, did anyone watch the tech ed videos from this week? What about the build videos talking about Windows WPA apps, like Windows Everywhere sort of thing? The idea that not only will the classes that you develop against actually be able to work on multiple devices, but even like the XAML code be able to work on multiple devices. These are the sort of things that Microsoft is really trying to invest in because they're obviously seeing that mobile is kind of a big deal, and maybe they should sort of think about investing in that besides making another Silverlight offshoot. So what portable class libraries do is do that abstraction of figuring out what is common between all these different platforms, and then being able to have you target that common set of features and APIs so that you don't have to worry about all those differences. That if it doesn't exist on this platform you're trying to target, then it just simply won't compile, as opposed to you doing this sort of project and all sort of stuff, which is what you had to do before portable class libraries. So why should you care? Well, for a long time, only really OSS library developers really should care, because for the longest time, portable class libraries only targeted, regular .NET. They targeted Silverlight, Windows Phone, and eventually Windows Store. So basically, .NET Framework and a bunch of stuff no one really uses. Until you started looking at what Xamarin is bringing to the table. That starting last year, Xamarin started to support portable class libraries, which meant it was actually feasible for you to develop libraries that could actually target these multiple devices with minimal effort on the developer's part. Before then, it was like no one really developed like WPF/Silverlight applications. Like that wasn't a thing people did. You either developed Silverlight or you developed WPF, but you really didn't do both. You might do something like a Windows Store app in Silverlight because not everyone has Windows 8. Most people, like most of my extended family, does not choose Windows 8. They're going to stay with Windows 7 until Microsoft figures out that this whole dual OS thing is a bad idea, and then they'll go ahead and adopt the next one. Vista Next is obviously not working, so they'll wait for the next one. But we're looking at mobile devices. This is where you really see, starting last year and coming to today, this is really why you see portable class libraries being something. I'll just say PCL because I'm tired of saying portable class library, being a thing that really mobile developers really care about. The other thing I found too is with PCLs, the other nice thing about it, even if I'm targeting one specific platform, it is nice to be able to, if I care about testing, to be able to test my application in a meaningful way. So we'll talk about that in a second here. So originally, PCLs were supported on VS 2012 and 2013. Honestly, though, with the recent announcements at Build and TechEd, if you want to do PCL work for a lot of devices and a lot of platforms, you really need to be on VS 2013. Because the way they're incrementally pushing out their updates and features, they're trying to roll out features more and more quickly, but it's only going to be supported on the latest platforms and the latest development environments. Xamarin, you don't have to really worry about it, right? Because it's like every other day it comes up saying there's an update for whatever SDK, and you're like, must be a day that ends in a Y, and you have to go update your stuff. So it's not really as big a deal there, but definitely if you're working in Visual Studio, that you really want to be in the latest Visual Studio to be able to cover all these different platforms. So something that happened last year, though, was the ability for portable class libraries to now target Android and iOS. So that meant that I could build libraries that can actually target all these different platforms very easily without a lot of effort from the developer. Now, there are starting to be divisions, though. So you see that between Studio 2012 and 2013, I started to see a division about what versions of these different platforms are supported. So if you really need to support Silverlight 4, okay, nobody. Or Windows Phone 7, because really? Like Windows Phone 8 is an 8.1. It's pretty amazing, so you shouldn't worry about Windows 7 anymore. Okay, then really you have to start looking at VS 2013. So the idea, I can now deploy my app to all the things. And then recently, actually I should change that, it's not RC anymore, they just dropped the latest RTM of Update 2 that I can now deploy to these now, they've now split this Silverlight versus Windows 8 apps. So they can develop a Windows 8 app, which is like Windows Phone 8.1, where they split it 8.1 between, I can develop a Windows Phone 8.1 app that can also run on Windows 8.1. So those little tile apps, they can run on both a Windows Phone and Windows 8, which makes sense because they're both tile systems, so why couldn't be able to do that before? It actually took a lot of work for those guys to do that because, is anyone here XAML developers? So XAML is really cross-platform. It's the exact same on all platforms, devices. No, it's actually totally different. Even the binding rules are different. It's ridiculous. So what they did, finally listened to developers to say, so don't dumb down everything, but can you at least build something that is cross-platform? So if I want to support both platforms, I'd have to build two totally different applications. So that's what they've done with the 8.1 release, is I can now build a single XAML app that works in both platforms. It works using the same principles as portable class libraries, and that it looks at the subset of both systems and says, well, over here you called it a button, over here you called it, I don't know, a clicky-do. So you can't do that, but if they're the same thing, we'll make sure we combine those two concepts into common namespaces and assemblies so that the behaviors are different on both platforms, but at least you have a common API to program against. So one thing that we've also seen with PCLs is that they left a lot of room on the dialogue for the supported platforms. There's kind of like a hint of like, well, there's going to be things in the future that they'll be able to support. So one thing they haven't formally announced yet that we kind of can see on the hype is the ability to deploy the same tile apps on Windows Phone 8.1, Windows 8.1, and maybe even Xbox One. That's what they've said, but it hasn't yet been released. So portable class libraries are the thing that enables all these different platforms to be able to develop by using the developer without having to do a lot of work to make it happen with all these crazy projects and different runtimes and references and all these things like that. So yes, all the things. One other thing that changed in the last 6 months is they changed the license of portable class libraries so that the actual library itself can actually be deployed on non-Windows systems. It's kind of funny, like Xamarin actually released PCL support before they were actually allowed to deploy, before you were actually allowed to deploy those. It was like 2 weeks later, because this was at, I think, Build or Publish or one of those conferences that cost thousands of dollars to go to. And they made these platforms available. This is actually kind of crazy. I mean, Mono existed as a thing that like 2 people used. But now you have the ability to actually deploy Microsoft-built components on non-Microsoft platforms. So that's new in the last 6 months. I don't think anyone here actually cares about that, right? You just do it anyway, because it works. But it's now like a supported thing as opposed to just kind of lip service, oh, hush, hush, don't, wink, wink, you know, don't tell, that sort of thing. So why do I, as an application developer, care about portable class libraries? A lot of it comes down to how I build applications. So has anyone here heard of the MVVM model of building applications? It's like it's a thing with letters. I don't know what the M stands for model, but no one actually says what it really means. But the idea is I separate my application into these different concerns of the view being the XAML part, the view model being the intermediary between sort of back-end services and the front-end views. So it does things like does all the binding. So you bind your view to a view model, so that's what you bind to. And it'll do things like handle any sort of events, commands. It's what I like to think of as like a code behind that doesn't suck. Really, as a view model, because it's independent of the view. Where code behinds in ASP.NET were these things that inherited from a page, and you couldn't really separate them out from the front end. So view models can be those things that have a lot of your interaction logic and coordination logic from what happens in the screen to what happens behind the scenes. So my view data binds to my view model, and my view model references any kind of models behind the scenes. With portable class libraries, what this allows me to do is build my views to be platform specific, but then everything else becomes a PCL. So if I want to have an application be able to target both iOS and Android, your views are never going to be the same. Everyone's here like been through the Xamarin boot camp and all that sort of stuff? Has anyone here used Xamarin before? Okay. So like once you get to the actual views in Xcode, like you got to switch over to Mac and you got to do your stuff in Xcode. But everything else behind the scenes, if you follow patterns that allow you to separate out that UI logic from being embedded in the view, what this allows us to do is then say, okay, Xamarin, let's do this part for Xamarin, and then the view part will be that platform-specific thing. So you get the real platform-specific controls. Now this phone gap baloney, you actually do real platform-specific controls, platform-specific UI elements, and nothing that's faked out. And then all the rest of the logic that really doesn't change from device to device, then that is the thing that you will build as a cross-platform component. And the MVVM model lets you do this. Now, this isn't the only model you can choose. So, if you want to do MVC or MVP, whatever it is, the idea is that the view is going to be the thing that lives on the device and is specific for that device because that's not cross-platform and never will be. But everything else that coordinates, kind of hooks things up, those are the pieces that you're going to look at saying, okay, let's make those cross-platform. Before PCLs, you'd have to do this entire stack, views, binding logic, everything behind the scenes, controllers. Those would be completely separate. In fact, a lot of the companies I talk to have completely separate teams. They have like their iOS team, their Android team, the Windows Phone guy, who is also like the Windows 8 guy. But these are like totally different stacks, and they're very, like the iOS guys are wearing ironic T-shirts. The Windows guys are wearing like ironic but sad T-shirts. So they're just different cliques, different sets of groups. But with something like Xamarin and PCL, I don't have to invest so much in having all these different teams. But I have to think about building apps in a very specific way that enables this. Otherwise, I'm going to be back in the land of having to build 3 completely different stacks. The other strategy I typically see people take is saying, I'm going to build a single API that everyone talks to, but I'm going to have different teams that build the actual front-end apps. That's the other typical approach I see. So you get a back-end team and a front-end team. Well, with Xamarin, I don't know about you, so I do client and server. I know both. I'm a full stack. I don't know if that's a bad word or not, but I can do everything. I can make wicked back-ends. I can make really ugly front-ends. I can do it all. But that is only possible if I can really work with this one platform. And so this is what portable class libraries allow us to do, is to work with one platform all the way from the top to the bottom. Now, what Windows Phone 8.1 and Windows 8.1 allow us to do is to extend this all the way up to the views so that even the XAML is the same between those all these different devices. Now, I don't know anyone that's actually building, besides the guys that are like developing, the DPEs, the platform evangelists that are actually building 8.1 apps. Is anyone here building Windows Phone apps? A few of you? Are you developer evangelists? No, I know you're not. Michael's not. Okay. So there are, but what this does allow you to do, though, is now even your XAML, all the way to the view controls are shared between 2 totally different platforms. Like, this is a totally different platform than this, right? They're totally different things. But looking at them, they look very similar. So the idea behind this is to take the same concepts and approaches that we're able to make this portable and extend it all the way up to the view. Before we go on, has anyone here actually developed with portable class libraries before? A few of you? So what I wanted to do is really dig into the nuts and bolts of how PCLs work. Because they're not magic, they're kind of a hack, but they work. And once you understand how it works behind the scenes, you can actually start to use those approaches to see how can I better build PCLs. So what I wanted to do is walk through a little bit of how PCLs work, how it works in Visual Studio, and then go all the way up to building an app that actually uses PCLs across different platforms, like actually multiple really disparate platforms, like maybe Android and Silverlight. They're like just totally different things, and see how it all fits together. I think we talked about this. Yes, platform activity. Yep. Oh, yeah, I actually want to show this. When building cross-platforms apps, one of the things I do run into is that there are going to be pieces that are different from platform to platform. For example, there's no such thing as system.data on a phone. Like there's not really a database here. That's actually changing because you can have SQLite on phones now. But for the longest time, you couldn't do like, okay, ADO.net does not exist on a phone. Just does not exist. There are multiple ones. So there's like security things, yes. Timer threading is another thing that doesn't exist on certain platforms. So you start to look at, there are things that exist on certain platforms you want to take advantage of, and then certain things that don't exist that you want to gracefully degrade. And does anyone remember like the whole idea of progressive enhancements from building web apps? Is that a term anyone's heard before? I've done web apps for way too long then, I guess. So the idea is that my application should be able to run on multiple platforms, but if a platform has features that I want to take advantage of, I want to make it as easy as possible for me as a developer to be able to wire in those enhanced features without having to do a whole lot of recompilation and a lot of rework on my system. So we'll be looking at techniques as well to say, well, if this platform has this feature and this one doesn't, how can I make it so that I can still have this nirvana of a single core platform system and be able to sort of add on these extra features as well. I will say that when you go to this ability to add on features and add on abilities for extra platforms, you do have to build your libraries differently. You actually have to think about how can I extend my system, how can I extend my library, my application, so that these new features are available. This is one of the things that we learned the hard way when we went from single platform to multi-platform, is that I don't want to give up all these cool things that existed in the full .NET framework, but I had to sort of re-architect my system so that those things could be plugged in at runtime based on what platform is running on. So I'll show some techniques as well so that you don't have to give up these features that you want to use on these different platforms, whether they're different or they just don't exist.
What kind of size of, I know the PCL you're doing single VL that you're using, but what kind of increase in file size did you see on the actual system?
Yeah, that's a good question. The question is, what increase in size do you see? We'll actually look at that.
Because I use my files right now for my cross-platform stuff.
Yes. No, it works fine. Until you add a file, like, okay, add.
Exactly.
Yeah, we'll look at that. All right, so let's look at, I'm just going to go to Visual Studio 2013. We're just going to create a new portable class library project and see what the experience is of going about creating one of these libraries. No. I'm going to go to high performance because we really want to hear this fan start spinning. All right, so all I'm going to do here is just do file new, portable class library, and we'll just see what pops up here. And one of the things that I found as well is that, there we go. So you have many different avenues in which you can create these portable class libraries. You can say, I'm going to create a Visual Studio C# Windows desktop. Oh, there's a class library called Portable there. I have Xamarin installed, so you see this iOS show up, but Portable doesn't show up there. So what I'm going to do is just create from Windows desktop a portable class library. Click OK. One of the first things that pop up is going to be, okay, what platforms do you want to support? So this is where you do have to decide about, what do you actually want to support in your system? For client applications, I typically know these are the platforms I'm going to deploy to. if you're developing a class library that you tend to share like in your company, this is a thing we see as a consulting company, see all the time, that someone creates some cool library to do, I don't know, really fast XML serialization. Oh no, you've only compiled it for .NET 4, but I'm running in this platform. So why don't you click all those checkboxes and come back to me when you've fixed it? So it really depends on whether I'm deploying a end-user application or I'm developing a library that's going to be shared amongst multiple people. If you're developing a library you tend to share with other teams and other people, you want to check as many boxes as possible, and you want to pick the lowest numbers as possible in each of these drop-downs. So I picked .NET 4 because .NET 4.5 has something I don't have. Immutable collections. Async await is through another NuGet package. I can get that too. I don't, other stuff. I can go look it up at other stuff. Windows 8.1, that is going to constrain me a lot, right? If I look at what's available in Windows 8.1, Windows 8.1 apps are heavily secured, right? They run in sandboxes, so you don't have a lot of the things that you normally have access to. But we're just going to go ahead and check all the things. One of the things we see down here, I don't have Zoom It running. Let me run Zoom It. Sure.
When you said you pick checkboxes based on what you want to support, are you saying that it limits what is supported by all the platforms, depending on what you pick? Is that what you were saying?
Yes, so the question was, based on what I checked, does it limit what is supported?
Well, let's say from Windows 8.
Mm-hmm.
With Windows 8, you have a checkbox. But it's not available, say, Silverlight, for example. Now, if it's Silverlight, that option will not be available because you want to have what's common amongst all of them. Is that what it's really doing?
Yes, and what you'll also see as well is there's a little, see down here, the following will be automatically targeted because they are already support the same set of portable APIs. So they've actually done the legwork and said, this is what we know is common between the different things, so we'll go ahead and say you can support these as well, based on looking at what's common between these different APIs. One thing we have seen is that, I mean, they're really taking things away. As newer versions come out, they're only adding things. So when I look at checking all these things, they don't add them to every single different piece. Like, ADO.NET is probably never going to get added to Windows Phone Silverlight. Probably never. So I don't expect that to ever just show up as a thing that I can use. So that's pretty much what it does. Is it looks at all those different APIs I'm choosing and says what is the subset of all the different supported things, and that's what you get. Another question.
Does it still use profile 134?
We're going to look at that. All right. He was a plant, actually. He's feeding me questions here. Yeah, so let's click OK. I just checked everything I could check. I could have picked Windows 8 as opposed to Windows 8.1, but it told me it's like there's no differences based on the other things you've chosen, so you can support that too.
So then the problem is, well, let's just say, if you pick 4 or 5 items, deploy in production, everything's working great, then you suddenly decide, you know what, we're going to do an enhancement, let's pick something else, whatever it might be. What you thought was okay previously when you deployed it suddenly becomes not okay.
And what you'll find is that, let's see if I can actually make that happen, because that is a situation. It won't let you pick that. It won't let you pick that choice. You'll pick something like this and be like, I don't know if I can make it happen actually. I'm just clicking around because I don't know. If I pick this or okay, so it will tell you that. I've seen it happen before where the choices I make say this is incompatible, or it'll gray some choices out. Before Xamarin had their latest release, like 2 weeks after build or so, Xamarin became unavailable for a lot of these choices because it said, based on what you picked over here, these aren't available for you at all. Or they'll take away, drop-down choices like, oh, I'll pick Windows. See, if I was in Visual Studio 2010, you'd actually 2012, you'd see this a lot more. Because if you pick like Windows .NET 3.5 and other stuff, it's like, whoa, a lot of the stuff isn't available, so you can't just pick Windows Phone 8.1 and this other thing because those are too far apart. So you get told at this dialog that what you've chosen isn't an option based on the platforms you've decided to pick. So it's difficult to see here because before I installed Update 2, this checkbox said Silverlight 4, and this checkbox didn't exist. Visual Studio 2012, you can't even open this solution because Windows Phone 8.1 isn't a project that you can open in Windows Visual Studio 2012. This is basically how they do it. They're like, you're going to pay more money for the next MSDN license so that you can support all these different things, which is difficult for OSS developers that want to support older platforms. So that picture I showed of like all the crazy projects, there are a lot of platforms out there that aren't supported by PCL, and they're stuck. And there's really nothing they can do about that because it does cost money and time and effort for the PCL team to support these older platforms, and they've kind of like, we'll focus on the future. Yes, so the question is, can I install additional targets? Windows Phone 8.1 wouldn't show up unless I had the Windows Phone 8.1 SDK installed.
What is the link to that?
The stupidest link in the world. Okay, so this link says I can install additional platforms, which is a trick, because the additional platforms are installed Visual Studio 2013. So if you look at some of these platforms, they're like, oh yeah, if I wanted to target this platform, I have to install Visual Studio 2013. What about Windows Store, included in Visual Studio 2013? What about PCLs? Oh, included, okay, Silverlight 5. Oh, nuts. It's only Visual Studio 2013. So basically, if you install Visual Studio 2013, you get these platforms. Otherwise, you don't. I can go click these other ones and get sad about what's not supported. Okay, so here you go. So if I get this update RC, I don't know. We probably won't have time to talk about how to make build servers off of this, because that's a whole different story if you don't want to install Visual Studio on a build server. But we can look at that too if you like. It's a whole other ball of wax. So the short answer is you typically need to install the SDK for the platform you want to support. If you install Visual, like they've tried to make it easy so that Visual Studio now includes all these SDKs by default. You don't have to go, I installed Visual Studio, now I got to go download an 8 gig SDK because whatever. No, Studio 2013 includes all those by default. So that little like go download other SDKs, there's no Azure PCL target. Oh, although based on yesterday's Tech Ed talk, there actually will be, but that's again a different story. But some of the others, those don't exist, so it's a lie. Like to install additional targets, if you're in Visual Studio 2013, you get the first 5 for free, and the last 2 you get with Xamarin. Good question, though. All right, so I compile this guy. Now, the thing about portable libraries is that a portable library cannot be run by itself. That is, I cannot take this portable library and just like start running code with it. Portable libraries have to be run on a platform for them to actually do anything. There's no such thing as a portable environment. There's actual real .NET Framework environments, but there's no actual portable environment. I actually need to take this and run this on a phone, on Silverlight, on the .NET Framework 4, or whatever it is. I need to run it in an actual, a real .NET Framework. A portable library by itself cannot just run. And I'll show you why. So if I look to see how this assembly is put together, I'm going to load up this library in .peak. Does anyone ever use Reflector? Then it got bought by Redgate. Everyone was sad and pitchforks and stuff. So I use either, what's the Telerik one is just compile, I think, or something. Just something. Yeah, just something. And .peak. So I want to go look to see what's actually in this guy. All right, so I'm going to open up. Where is this guy? thought there was an open folder. That's fine. You can mind your own business. Thank you. We'll get there together. Okay. Yeah, so someone said something about profile, something. So one of the things you'll find that when you build a portable class library, that they target what's known as portable class library profiles. These profiles are how the .NET team decided to create something that you could actually compile against. And you'll see what I mean when I actually look at the references here. So this class library, it says it references MS Core Lib 2.0.5.0. Do you know what that stands for? What version? What?
Core library.
Yeah, what does a version correspond to? Silverlight 4. I know this because I get GitHub issues in my OSS libraries like, why are you referencing Silverlight 4? I'm not. This is the lowest assembly version of MS Core Lib for all the different portable frameworks I could target. So let's look at this guy. MS Core Lib. Let's just see what's going on here. Let's just peek under the covers. What's going on? This crazy thing that has to target all these different platforms. How is Microsoft consolidated all their code across all these different platforms? Have they done the if-def hell? Right? I mean, are they having to target all these different things with this crazy stuff? The answer is a little disconcerting. Okay. Activate or create instance does nothing. Wait a second. Activate or create instance is how you can use the type metadata to create an instance of an object based on a type object. And it's probably supposed to do some pretty crazy stuff. Probably not that. Probably not return null. So something's going on here. Something is... I mean, obviously, when I run this application, when I use this library, if I try to use activator.create instance, it's probably not doing that. So what's going on here? Well, it turns out, if I look at the properties here, and I go look up the location of this guy, you'll see that you'll have all these different profiles, and this one in particular is the profile 328, which guys that do a lot of cross-platform development actually know these profile numbers by name and what they mean. Ridiculous. And here's where you actually see the different portable class assemblies that you can target as a portable class library developer. So you as a PCL developer can reference System Core, which gives you all the link stuff, right? MS Core Lib, which is, you know, BCL, just everything. System net, system runtime serialization, system that's something no one should ever use ever again. XML serial. So these are the things that actually do exist across all. These are the assemblies that are available across all these different platforms. You don't see system.data, right? That system.data does not exist across these different platforms, and you also get all the localization stuff as well. But the implementations of these guys do nothing. What actually happens at runtime is that these assemblies are configured to actually forward these calls over to the real platform-specific calls. So at runtime, instead of your application calling into this assembly that obviously does nothing, it will actually call the real assembly that does the real stuff. So at runtime, it will call MS Core Lib proper 4.0 .NET Framework or whatever platform you're running at, so that whatever crazy stuff that happens behind the scenes will actually get called based on that platform, and it will know this when your assembly actually gets loaded. So instead of you may be referencing this version, it'll automatically get forwarded to the right version without you having to do any sort of crazy assembly redirect binding junk at all, which is normally what you have to do if you want to reference a higher version of a strong main assembly. You have to say, okay, I know you wanted to go against this version, but actually, can you go against this one? They made fundamental changes to the assembly metadata to allow you to automatically forward over calls from this assembly that does nothing to the real one on your actual library. The question earlier was, what is the size difference here? When I'm looking at something like this, the size difference is nothing, because at runtime, the real libraries I reference that are not mine are the actual platform-specific libraries. My library itself, there is no real change in how big it is. And we can look at that. So let's go to back. I'll create another class library that is not this. And let's make one, I don't know. What do you want to make? Silverlight 3, Windows Store, Universal. That's another portable one. Let's make a Windows Phone. Somewhere here's a class library. There we go. Windows Phone class library. Those are pretty much exactly the same thing. You look at the references, they reference similar things. The only thing that you see that is different is that this says it just references .NET. Okay. And this one says it references some version of the .NET Framework SDK with Windows Phone 8.1. Looking at the assemblies, though, obviously they're going to be pretty small, right? This is 4K, which isn't that the minimum size limit for portable? And going back up, also 4K, so unless I looked at a real one, I probably wouldn't get a good idea, but that's actually kind of hard to do, to take one that's not portable, make it portable, and make it still compile. But the idea is that the code here doesn't change. The IL looks exactly the same. The only difference is when I look at what it's referencing, it says I'm referencing something that is going to be switched out by something else at runtime. So it says it's referencing the MS Core Lib 2050, which is a fake version, but at runtime, actually, this thing is going to be used. So it's just binding at runtime to different actual assemblies. Otherwise, my assembly itself doesn't change at all. So I take this assembly that was compiled once, and I can deploy it to as many different deployed frameworks as I've decided to choose here. Does that answer your question? All right, so that was a boring one. So we looked at what the assembly looks like. We looked at what the reference looks like, and we finally looked at what it looks like in the .NET framework. And if I go look at it on disk, where this guy actually exists, we'll see that there's this crazy set of these different profiles. And what these profiles are Microsoft analyzing basically all the combinations of different checkboxes you could check and that dialog, and saying, let's make an mscorelib.dll that represents the subset of all those APIs that you've chosen, so that you can actually have something to compile against. When you compile your application, you're compiling against one of these DLLs that exists in this folder. We can actually use this, as we'll see a little bit later, to our advantage to say, what if I want to be able to use Microsoft's same trick on my portable library? We'll see if we get to that, because that's kind of a crazy thing to do. But if I go dig into any one of these guys, you'll be able to see, here's the supported frameworks list, and it tells you exactly what are the supported frameworks for this profile. You should never really care about this. You should only really care about that first dialog about what checkboxes you want to check, which drop-down choices. But just to give you an idea behind the scenes, this is how it's all put together. These XML files actually drive those user interfaces and what's actually available to what. In fact, before Xamarin support officially came out, if you just dropped XML files in the right folders, you could magically get portable class library support. Whether or not it actually ran is a different story, but again, this is all just a compile time trick. PCLs are a compile time trick to trick you into think trick you into compiling against something that doesn't actually have any functionality. But when you run it, because you don't run portable by itself, you run portable libraries on a platform, At runtime, the real version gets swapped out. So the only trouble you can get to is that Microsoft didn't do their homework and accidentally exposed an API that didn't really exist on this different platform you're trying to support. Any questions so far? All right. So that's all fun and games. Why would I, as a developer, really care about this? The first thing that I saw that even if you're not a cross-platform developer, that is, you're only developing for one specific device or one specific platform, that is not the .NET framework. Then one of the reasons you really might care about this is for testability. And I'll give you an example of this. So let's close this guy. I'm going to create a new, I have Xamarin here, I'm going to create a new iOS app, a iPhone Hello World application. Hooray. I'll have a quick answer.
The Xamarin for Visual Studio, when I was looking at the site, it was saying it only comes with the full developer version. Is that true? Or
Business edition?
yeah, in other words, I was under the impression that when you're just learning the stuff, you can get a free version of stuff to work with, and then when you actually want to deploy it and stuff, there's a licensing on it. Is that true of the Visual Studio version as well?
Yes, the question is, are there limitations in licensing for Xamarin, specifically iOS and...
Well, for the Visual Studio plugin. Is that
I'm sure there are, because Microsoft does not want you to use Express. They want you to buy MSDN. So offhand, I don't know, because they haven't been expanding what Express can do for ever since they released it and realized no one can use it. But I don't know for sure if you can use Xamarin with Express.
No. I'm thinking about. I have my Visual Studio 2013 full version.
Okay.
I'm not talking about Microsoft.
You're talking about Xamarin? Oh, okay.
There's some different versions of Xamarin.
Yes.
It seems like only the most expensive one has a Visual Studio plugin.
I believe so. I believe it's the business edition that gives you that.
So is that something that also falls into that idea that until you're actually going to start publishing this stuff, there's a...
Okay, so it's probably a different conversation to talk about why would you use Xamarin versus Visual Studio. Xamarin Studio versus Visual Studio. It typically comes down to, do I like ReSharper? Do I like high CPU usage, high memory usage, or do I like Xamarin?
Okay.
If I want it to work, Visual Studio. All right, so this is an application that is using Monotouch. I don't have an iOS developer account, so I can't actually deploy to this thing here. Turns out, and I'm too cheap to spend $100 a year. So this is something that, okay, I have Xamarin installed. We'll not do Xamarin iOS. But if I wanted to take this, and I have a lot of code behind this application, and let's say I'm going to create a test project out of this. I have a lot of logic going on behind the scenes. I want to now test this. What is the testing story for Xamarin these days? Let's see. Right-click, add new project. Let's look for the iPhone test project. iPhone test. iOS unit test project. Okay. So I can use iOS unit test project to unit test iOS stuff. Okay, now how does that actually work in a build server? Well, it doesn't, because I have a map attached to it. So if you're doing something like, even if you're just saying, I'm just doing iOS or Android development with Xamarin, but you want to do something like unit testing, using the normal unit testing frameworks you know and love. Typically, when you see unit testing frameworks for platforms, you have to use that unit testing platform. So if you're going to build unit testing, build unit tests for Windows Phone, it's like there's a Windows Phone unit test thing, which actually pops up an emulator and does stuff. It's like, well, that doesn't work too hot on a... Has anyone ever tried to have unit tests for emulators work in a build environment? Did it work? I mean, it takes so much work. I mean, the Windows Phone one was the worst because it was a red or green display on the emulator to tell you success or fail. Like, TeamCity, they can't see green or red. I'm sorry. So this is one of the things that Portable can have out, is if we're able to take the code that contains our business logic, take it out of the platform-specific project, and instead make it a portable project. So do something like, I should have done iOS because like, let's do something else that's not gonna flake out on me. I love Xamarin, but like, flip a coin if it works. Honestly. What?
What channel are you?
You know what probably is going on is I have another Xamarin, another video instance using Xamarin. So my build host is, because everyone knows about build host, right? There you are. Hey, Xamarin. Let's build something else because I want to see something not. Let's just do a Windows Phone app. So Windows Phone app does have a unit test app, and that's really just an app to run unit tests in. Now we'll say that it is still important, even if you're doing portable, to run on your device because it's only going to load the actual target framework assemblies in that target framework. That's the only time you're ever actually going to see it running the real stuff. But because I'm programming its common APIs, it's probably, I can probably count on it being the same behaviors across platforms, unless I'm doing something really crazy, and they'll call it out if I actually am. What I've seen personally is that, let's do something, hub app, I don't know, something I can see something in. It's still going to take parallel because this is Parallels, which is a VM, and trying to run the emulator on a VM is just awesome. So if I wanted to create a unit test project off of this, I would have problems because the things that the normal unit testing libraries I want to use, things like maybe I want to use XUnit or maybe I want to use NUnit. Well, NUnit doesn't have a Windows Phone compatible version. So what do I do? Or if I want to use anything else like should or shouldly or MockU or EasyMock, like those don't exist for other platforms. So what do I do? Well, what you do is you create a library that contains your business logic, however you want to define it, whether you do MVVM or whatever. You create this base project that contains your real business logic, and this one is the one you make portable. So this guy, you'll say, okay, I don't need to target all the things. I'll just target, okay, this one is Windows Phone 8.1, so I'll just check that one box, and then the other checkbox I'll check is the thing that is going to be used by my unit testing project. So this one I'll use .NET 4 because I know, in this case I'll just use XUnit because whatever. And, you know, it's got some calculator, class, whatever. Because I'm just not that creative. Like, I wish I had something more exciting than this, like a to-do app or something, but this is all I got. All right, so this library is something simple, and I can make my Windows Phone 8.1 app reference my class library because it is one of the supported platforms. And I'm not using anything crazy in my portable library that is not supported by the platform. In fact, because I'm referencing it, a very specific platform, Windows Phone 8.1, those additional types that might exist in Windows Phone 8.1 aren't even visible to me. So I won't even compile. I won't even know about them. So I can't get myself in trouble. Okay, so I can have my app reference that one portable class library that has my calculator, and then I can create another one that is my unit test project. In this one, I'm going to create a regular class library that is just, unit tests. And using just NuGet, internet, yes, I can now, after initializing the host, I can install XUnit. Now to that unit test project, And it works just fine because, hey, it's just a regular .NET 4 library, this unit test project. Okay, everyone get off Dropbox and BitTorrent. Oh, there we go. It works. And in my unit test projects, can add. I can reference that same portable class library that is referenced by my Windows Phone app. Equal expected 3 and actual is that thing. So now all of your calculator apps are testable. That was a bad joke, I'm sorry. Oh, I need to put the semicolon. Too much JavaScript where I leave off the semicolons. Once and abandoned. So this is actually running, this one application, this project, is actually running the .NET 4.5.1 framework. My portable class library targets .NET 4, but it's all a sham because it's just referencing an empty assembly with no actual behavior just to help it compile. But at runtime, it's running the real .NET framework. So the portable class library helps me constrain what is actually available in both my unit test project and the real application. So I can't do things like, well, I mean, I don't know what else you test exactly. XAML binding, you don't really do that, right? You run it to figure out if it actually you can see it actually running. But everything else, all the business logic, if you're using MVVM, all your view models, all those things can now be unit tested without worrying about having to pick a very specific target unit testing platform. Now, Microsoft does have unit testing frameworks for some of these platforms, but that doesn't mean that all the other unit testing tools you like to use, like mocking and things like that, are going to be available to you. So by creating a portable class library for your base common business logic, it makes it much easier to have that unit testing behavior, as well as be able to integrate it into your actual builds. Now, TFS does have CI for some of the stuff, but if you're using basically anything else, you're kind of SOL. So if you want to do unit testing with some of these things and you just want to use TeamCity, this is the easiest path for you to do. Just say, you know, the front end stuff is going to be that portable, going to be the platform specific application. Everything else, business logic, whatnot, will be a portable library that I can now have unit tested with my unit testing project. Now you could say that, okay, unit testing is a good thing, but should I totally change my architecture just to be able to do this? Yes. Sorry. Because otherwise, like, if you, I mean, everyone here is mobile developers, you know how crappy it is to like constantly deploy your app to the device to make sure it's working. If you can take all the business logic and shove it to something that's like, you know, very fast feedback, and then the thing that's difficult to do, the things that's like, okay, does the, when I click, you know, is my UI event correctly bound to me touching this thing? Well, that's the sort of thing that's only going to be able to be known on a device. Everything else, though, you might as well take it out, put it in a PCL, and have it unit tested, so that you have some confidence that, you know, the base of your application is working. But it's just, you know, that very top layer, the views, that you really need to run on a device to see all the interactions wired up. I will say too, if you're using more advanced UI frameworks that do all this binding for you automatically, even that piece you're going to have a lot more confidence in. If you're using something like MVVM Lite, if you're using something like Reactive UI, these are the sort of things that make it really easy to do those binding pieces that bind front-end view stuff to back-end events and back-end methods. So even that becomes, you have much more confidence that the UI is actually wired up and is running correctly. And so what I typically see these days is that the business logic of my system is in a PCL being tested behind the scenes in C#, and the front-end stuff is what the front-end guy worries about, like making sure all the UI elements are correct, that they're laid out appropriately, the transitions are correct, that's all good. But we, instead of having this big division between you know, the iOS guy and the API guy. It's much more like app behavior and then just like UI layout person. Which I guess sucks for them, but you know, whatever. All right. So this all works fantastic when everything is the same across all platforms. When I'm only using the subset of those checkboxes I've checked. That's not always the case. It's not always the case that the checkboxes I check enable me to be able to have all those different things at runtime. So what I wanted to show is some techniques to be able to have different behavior on different platforms. And remember, what time are we going to? How late are we going? I'm not going to go till 9. I can see the flying saucer from here. We're not going till 9. Okay, so the first thing I wanted to show is an example of an application that is using the MVVM pattern to share this common behavior across multiple different platforms. This one's called a portable notepad, and this one is an application that's running under one platform that people actually use, and two others that two people here use, I guess. So the main application, the main core business logic is in this portable library that is using a view model to bind up to the front end. And each of the front-end applications, whether it's Windows Phone 8, Windows 8, or WPF, is then binding their XAML views to that view model. The view model is where all the behavior actually lives in this application. So look behind the scenes, and this is, let me just run it, and that'll make more sense. Let me just run this guy. This is a notepad application that can run in multiple environments. So I can EFW mobile net.txt. All right, we'll click save, and allegedly this should save something to my desktop. Something is really messed up with my. I thought it saved it to my desktop. Maybe it saved it to my documents. Let me check real quick. Yeah, desktop file storage. TFW mobile.net.txt. Well, it was supposed to do something there. It doesn't like that file name. Okay, well, we'll just pretend it actually sees the file for fun. So the idea behind this application is that it's a notepad that is supposed to save files and load files and be able to edit them. Very exciting stuff. I mean, why we need to use Notepad, I don't know, but we got a portable version, so there you go. But looking at these different environments, a Windows Phone app is going to store files in a very different way than a Windows Presentation Framework app versus the Windows Desktop app or Windows 8 app, Windows Store app, whatever it is. They have very different places where they're actually allowed to store things. So what I have to do, though, in this case, is based on the different platform I'm choosing, at runtime decide what's the best way to save a file. And one of the techniques you can use is a technique known as dependency injection that says, okay, my view model, which is portable, knows it needs to save a file in the save file command, the save command and load command. And the save and load commands will save and load a file based on my file storage. My file storage in my portable class library is only defined as an interface. So there's no actual implementation based on the target platform I'm running on, or the portable library application. So when I look at use or derived types of this, there are going to be 3 derived types of iFile storage, none of which exists in the portable library. So this is the case where there really is no common behavior between these different platforms, and I have to create an adapter interface atop those different, or facade, one of those two, across the different possible file storage APIs on those different platforms to say, on this we're going to use this, on that we're going to use that, on this one we're going to use the other. So based on each individual platform, when the application is loaded up, I want to look at the code behind here, not the XAML. On the WPF app, here it is, main window. When it instantiates the view model, which needs an iFile storage interface, in this example, it's actually going to use a desktop file storage implementation. So I'm creating an implementation that only exists on the desktop. So I determine my abstraction, this iFile storage interface, and then each platform is going to have a platform-specific implementation that gets wired up at runtime. So the desktop file storage is supposed to load and save things to the desktop. I don't know why I did it. Okay, it just catches and does nothing. Awesome. And in my portable library, or sorry, my Windows 8 app, it's going to be loading and saving into Windows storage, into app data current local folders. So this is application data local. Yes. Not roaming, not the other, this one. And then finally, my WP8 app, it has its own Windows Phone 8 storage for isolated storage. Now, these things, this isolated storage and the Windows 8 storage, this app file storage, those namespaces and types don't exist across platforms. So when you have these cases where you really need to have platform-specific functionality that you need to have some common interface for, this is how you do it. You create an interface that represents the commonalities between all these different APIs, because Microsoft hasn't created this common API, and then you provide implementations on each of the target platforms that you deploy to. Ideally, you don't have to do this. Right? It'd be nice to not have to create these platform-specific pieces or these differences that you have to run into, but in reality, I found that it's inevitable, that you're going to have pieces that just aren't common across these different platforms. You're looking at this is Windows storage application data current local folder. And Windows Phone 8, it's isolated storage, like totally different API altogether, just completely different. It would be nice if there was a common, like, I need to store a file somewhere, I don't care where, just somewhere. Across all platforms, that doesn't exist. So we had to create it ourselves. But it's not that hard to do. We just create an interface that's the common API between all these different pieces, and then provide implementations based on each specific platform, and it still works just great. If you find yourself in the situation that you're building a portable library where you're finding most of your application logic is actually in the platform-specific projects, PCL is probably not going to buy you much, to be honest. There's not enough commonalities between your different systems. But the ideal situation is that most of my business logic, again, lives in this common core thing, and when I have things that have to talk to devices that are really specific to the platform I'm deploying to, then I provide abstractions for those pieces and deploy those platform-specific pieces based on those individual devices and only depend on those abstractions. Let's run the Windows 8 app. I don't think I've run that one before, just to see what that looks like. I don't even know how to deploy one of these guys. There we go, debug start instance, right? That'll always work. Yeah, it looks great. Oh, there we go. Okay, so I'm going to change the text. I'm going to hit save. And if I close it, if I run it again and I load that file, it should have the same text. That's the idea. I click load. Okay, so it had the same text. I don't know where to put it on disk. Some local something. Even crazier if I run the emulator, just gets, that one wouldn't work because it stores it on the emulator itself, so it really just go away. But in this case, at least, I can see it safe and load just fine. Any questions about the platform-specific approach using dependency injection?
What if you need to call something way down deep, like suppose that getting the current date time was not supported across all platforms. So date time now.
First thing first, in your portable library, so the question was, what if I have to have some like really down deep API? The compiler will fail anyway. You won't see that thing you're trying to touch because you've already picked that portable library that is in that profile folder that's already cut out everything that isn't cross-platform. So it's actually pretty rare. It's what I usually want to do is that I need something that doesn't exist across those platforms. So I have to provide some extension point or abstraction to be able to hook into that. So something like datetime.now, you'd have to not use datetime.now, but you wouldn't be able to because it wouldn't compile. So I've typically found that it's in your face. Unlike the compiler directives, where I find out the compiler in this project, it works everywhere else, and I got to worry about what to do. With PCLs, like it's not even there. You don't even see it. One of the things I do find, though, as I move from a library that's not portable to portable, you will find that not all of, even if something actually exists across all platforms, it may not actually be available to you. Because Microsoft has had to do work to create these common APIs, sometimes they've gone and backfilled some of the other platforms to be able to support stuff. Sometimes they don't. Here's an example. Activator.doStuff. If I were to look at Activator for System 4.0.0, Activator for this, not this profile version, but for this version. Where are you? Okay. Maybe not there. Maybe over here. It's still confused. Okay. Well, what I've found sometimes is that even when I'm looking at a specific class or type, that occasionally not even all the overloads are available to me, or all the methods. So you will find yourself like, well, I'm using this method, but that method is not available on that type. So I got to use this other method that has like, 5 other parameters to get to pass in. That was one of the things I found after moving a library from non-portable to portable, is that even if the class is available, even if the method's available, sometimes the overload isn't available, so I have to go fix that. Just some weird stuff I found that, I didn't know that method was not available in Silverlight 4, so I got to go change my code to call that one overload. Yeah, man. You cannot use compiler directives in a PCL project. Those compiler directives do not exist. So I go look at this guy, go look at the portable, you go look at the project properties and the build, where you normally see those symbols, they don't exist. So you can't even use that. Because again, this is when the platform runs, it gets retargeted at runtime. Whereas compiler directives are based on your target platform, those different things get applied. So if you use compiler directives, you have to compile multiple times. The file has to be compiled multiple times. Where if I open up, Windows app, that's where you'll see those compilation symbols come into play. So using link files, you could still do this with this solution. You could say, well, I've already got an existing app. Okay, I don't want to break stuff out. I don't want to create these abstractions, whatever. For this one file, I'll take it and make it add as linked to all my different projects. That's still a viable solution. You'll find yourself in weirdness, though, because your application specific projects have to reference the portable class library. You may run into, well, it used to be in one assembly, now it's referenced, so now you're just like, oh, it's not referenced, that sort of thing. But this one, you still do get the normal, compilation symbols that are available to you. Okay, so That was the easy way of doing cross-platform development, where I have different behavior running in different platforms. Sometimes things can get a little bit more complicated. So I wanted to show an approach where in this case it was a explicit injection of behaviors into my system. So in this case, they actually, I said this is the implementation you're going to use. If I have a lot of those things I have to do, I may not want to have all this wiring up of all these platform-specific pieces. So another approach is to have a portable library, have platform-specific libraries, and then platform-specific applications. This is kind of your last resort, honestly, of building platform-specific features, but it is something that is available. If you don't want to have all this wiring up of all these very platform-specific things, what if instead of this being explicit, what if it just sort of discovered the platform-specific behaviors at runtime? And that's the last approach I'm going to show. So this is my library, AutoMapper, which this technique I didn't come up with myself. It actually exists in the portable extensions projects in Codeflex. Portable, not portable. Extensions, Codeflex. PCL contrib. Sorry, this is the one. I actually borrowed this approach from these guys, who they have a lot of common helpers and things like that for building PCL. So if you're building a lot of PCLs, check this project out. It has a lot of stuff that's really helpful to be able to use across different projects. Things like types that don't exist cross-platform, they'll fill in the missing pieces. I've done things like, this monitor class does not exist across platforms. How about I grab the mono version and compile that in instead? That's also a possibility. If you find yourself needing a class or type that's not exist cross-platform, you can't grab Microsoft's version, but you can grab the mono version instead. And that'll just be a drop-in replacement instead. There's been a lot of like core types that don't exist, especially around threading and locks and stuff, that I'll just go ahead and grab someone else's version out there and use that as my own, and correctly license and whatever. So I dug down into their source code. I won't go all the way down, but somewhere in their source code, they have this ability to be able to have adaptation. This idea of being able to dynamically resolve platform-specific features at runtime. So if I have a lot of platform-specific functionality and I don't want to leave platforms out, the idea behind this is that I can have the base library discover platform-specific features. This is something that's not new. Doing here was a web developer when ASP.NET 4.0 came out. There were a lot of ASP.NET 4.5 features between 4.0 and 5 that just lit up in .NET 4.5 that didn't exist in .NET 4. And so what the ASP.NET 4 runtime would do is check to see if .NET 4.5 was installed and use those features instead. And that's what this is going to do. It's really hokey once you see it, but I promise you it works. If I have something that is truly different across different platforms, then what I can do is I can go to a common class that I want to ask it for an implementation of something. And at runtime, it's going to probe my current loaded assemblies and see if I have a platform-specific assembly that could have a better version of what I'm trying to do. For example, there's no multi-threading on Windows Phone, but on other platforms there is multi-threading. So what if I was able to make the common behavior the single-threaded version, but if I'm running in a multi-threaded environment, it uses the multi-threaded version. And the developer using this doesn't have to think about that. It would just automatically use the best version for whatever platform that is going to be run. In order for me to do this, I need to have a mechanism to be able to resolve my platform-specific assemblies at runtime. It sounds like crazy hokey, but it's something that even Microsoft is doing in their libraries. The idea is I know the known platform-specific assemblies beforehand, And what I'm going to do is I'm going to probe my directory for assemblies named this. So x.net4, x.net WinRT, and I'm going to look, because I can't now really detect what platform I'm running under, I'm just going to look for these other assemblies. And once I find that assembly, I'm going to ask that assembly to resolve a type. And what it's going to try to do is find a type that is called the type I'm looking for, plus override. Like I said, it's extremely hokey, but it's a way for us to say, this, instead of me telling it explicitly, override this type, I will just look for a type called override and use that one instead. And I have a lot of these guys. I've got dictionaries. So in .NET 4, Windows Phone 8, Android, and iOS, there's a better dictionary override that is a concurrent dictionary. The concurrent dictionary does not exist in all platforms. But for multi-threaded applications, it does exist. So when I want an iDictionary, or really a concurrent dictionary, I want for the libraries that have a concurrent dictionary to use that one. Otherwise, fall back to the normal dictionary of T. Another example. What's another one? Delegate Factory. Dictionary Factory. Delegate Factory is a good one. So this is one where some of these features don't exist in different platforms. So for example, I cannot set fields and expressions in Silverlight. I mean, like, okay, that's kind of a weird thing to restrict, but it's like this, I have all my portable class library. This one little thing didn't exist. So how could I override that? Well, I'll create a virtual method for that one thing, and I'll override that uses a better version of it. In this case, instead of using reflection, which is slow, it uses expressions, which is fast. But I don't want to eliminate those other platforms from using this functionality, so we'll have like the base kind of crappy version, but it doesn't matter because you're on a phone, and the better version for the platforms that support this. And at runtime, whenever I ask for something of this type, it will find a type that is called override, and we'll use this one instead. And my portable class library is none the wiser because everything in my portable class library is calling this resolve, which is basically a service location pattern. I'm looking for a service of this type, and if I'm on a platform that has a better version of it, it grabs that one instead. And now, my platform-specific libraries can extend what they are able to support based on what's available on that platform. So .NET 4 can support data reader. So ADO.NET exists in .NET 4, so data reader is supported here. If I go look at Silverlight, it doesn't exist. So they don't get it. But they don't care because it never existed anyway. So that's that. So my platform-specific libraries now contain those overrides for those platform-specific features. Hopefully you don't have to get this far. But if you do, just lean on what other people have already figured out and say, I'll use a service locator pattern to ask for a service of some type. And then at runtime, it'll probe my directory for an extension, a platform-specific extension library, and load like the better version of it. You can take this to the extreme. I was actually I popped this open for Amara, I guess, and how did I lose my? Yeah. So there's actually another trick. This is called the bait and switch PCL trick. The same trick. This is from Paul Betts, who created the reactive UI library that's this cross-platform reactive extensions for building stuff that doesn't suck as hard as XAML binding. The same trick that Microsoft used to create blank implementations that do nothing, replaced by the real implementations, you can do yourself. I would only use this if it's like a complete replacement, though. Like that replacement we had for the file storage, that was actually a good example. Because the way the .NET Framework probes for types, it'll probe my platform type first, and then it'll probe the platform type. And if I make that base type do nothing, which is basically what he's set to do, He's going to make beep, 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 beep. I don't know. You can look at the implementation here. He basically, the same thing the .NET Framework does of making it do nothing. We can do the same thing ourselves, and NuGet will use the right version at runtime. It'll reference the right version, and everything will just be put in place. I want to show the last little thing with NuGet here. So I have a library that supports cross-platform. So what I'm going to do is, well, my Windows Phone 8 app show how that works with NuGet. My library supports all the things. But for this application, it's only going to specifically reference my PCL version, which has the base core functionality, and the platform-specific version. If I actually go dig into the packages folder, here we go. We'll see that all the different platforms actually exist in the package, but what's actually only referenced is the ones that are supported by my platform. So in this case, I've got a portable version that supports Windows Phone 8.1. Okay, so this DLL is going to get referenced, and I have a Windows Phone Everywhere 8.1. I don't know what the A stands for. Application. What's the P stand for? Because I can run it on the Windows Store app too.
Well, that's a Windows Phone application.
They can also run in Windows RT. I don't know. Anyway, so NuGet will take care of making sure the right platform-specific assemblies are actually referenced. So if you build these platform-specific, build a portable library and platform-specific libraries, NuGet takes care of all the dirty work of making sure only the ones that are targeting your platform actually get referenced by your project. Yes, so only those two, even though all those other ones exist, NuGet knows only do those two, and that's it. So, just to sum things up, go back to who should care? Again, for a long time, the people who care about PCL are really OSS developers. The people that are building the libraries that you use in all your projects, you know, the Ninjax, the Autofax, those are the only people that really cared about PCLs for the longest time, until Xamarin came around and said, now Xamarin supports PCL, which means I can build applications that can truly be developed cross-platform. That's great. Until you run into these issues where not everything you want to use is cross-platform. So I have to change how my applications are built. I have to use different platforms, different patterns, different architectures to be able to maximize my use out of PCLs. And for you that are just supporting one platform, what I found PCLs really help with is this ability to build a core testable API, and then only the very top layer that is the actual user interface that isn't testable anyway except for on device, that is the piece that I don't, that is platform specific. So for more reading about this, the .NET blog is a really good resource for this. They have a lot of good resources for building PCLs. Otherwise, beyond that, Xamarin's also got a lot of resources on building cross-platform libraries, especially targeting all these other devices. Otherwise, the Channel 9 website from Microsoft also has a lot of good stuff that just came out on from Build and from TechEd that talks about their expansion of support for portable class libraries. Even as far as like having Miguel come on stage, which is crazy. The Microsoft guy would be like, oh, mono, it's a thing. So thank you guys for having me. Do you have any questions? I'll be sticking around here, or otherwise, have a great evening. Thanks a lot.